Welcome to this PanelPilotACE tutorial video. Today I'm going to be talking to you about the RS232 on the PanelPilotACE. So before we begin going into too much detail, I should probably tell you a couple of things about how the RS232 on the PanelPilotACE works. Firstly, it's important to understand that the RS232 at the moment is purely ASCII based, so you won't be sending integers, floats as anything other than an ASCII string. That makes it difficult, non-ideal for machine-to-machine communication, but if you do control both bits of hardware, you can make it work quite easily, as long as you're willing to sacrifice some of the bit rate. We do intend to add machine-to-machine communication, and I'll explain to you how that will work in a bit, but for the moment you are limited to ASCII communication with predefined delimiters as well as endpoints. So in order to use this, you will need to connect your device up to, in my example I'm going to use a terminal application on the PC. Obviously you could connect it directly to your RS232 device. I've got a RS232 to USB converter, which I've got plugged into a PanelPilotACE development kit here, which brings out the RS232 ports. Otherwise, the connectors are on the back of the PanelPilotACE. You can take a look at the datasheet for more details on that. Okay, so let's get started looking at the elements then that you'll need to create your first RS232 application. So firstly, there are three main elements. You've got one hardware element which defines the hardware protocol. You've got two functional elements. Now these, one is for a send and one is for a receive. So I'll talk you through all of these individually first, and then we'll put them all together and come up with a quick application that we can use an example. So you'll see I've already got a serial COM port in here. This can be found under the hardware elements. So here you go, you've got serial RS232 and serial RS485. So I'm currently running the beta version of the software. You may not see RS485 if you are on the standard V2 software. But don't worry, that'll be coming soon, and the elements work in almost identical ways. So, for simplicity's sake, I'm just going to talk you through the 232 COM port. But as I say, the 485 is virtually identical. Okay, so going through the properties, we have your name, that's completely standard. Channel, now this is for future support if we have more than one channel for the RS232. You'll see at the moment there's no drop down because there is only one channel available. Service type. So this is an interesting property. So native refers to panel pilot to panel pilot communication. Now what this enables the user to do is to talk to another PanelPilotACE, and because we're talking to another PanelPilotACE, we can format the data in different ways. So for example, we can add verification, CRC checks, etc. Because both ends know what is being done. However, today I'm going to talk you through the terminal application, which is probably the most common application you're going to need to know about. So we're going to leave that on terminal for now. So now you've got all of your standard RS232 properties. So baud rate, it's obviously the speed at which the data is sent. Now if you're using an RS232 to USB adapter, it's highly unlikely that this is important, but if you're going directly into RS232, you may well need to set this to the correct value. So you should be aware the device you're connecting to should specify what baud rate is necessary. The same for the parity and stop and flow control bits, variables. These are all predetermined. You should be aware of them if you're connecting to another RS232 device. Okay, so moving down. Next up you'll see terminal mode. So again, this is probably something that could easily confuse someone looking for the first time. It's not a standard property for RS232. So what this does is it enables us to control how the data appears. So there's two main types here. You've got raw data and prompt types. So raw data is what we're going to use if we're talking to a device. If we don't care what we see, we're not looking at it ourselves. Whereas prompt, I mean, that's going to look like almost a Linux terminal where it prompts you to enter data. Fixed prompt means that the prompt stays still, and a scroll up with prompt means that the data scrolls down the screen as it goes. I'll give you an example of those so you can see exactly what they look like when we get to that point. So as I say, single and multiple raw data basically refers to whether we're expecting more than one variable to be transmitted over the RS232. I would normally just stick with multiple raw data unless I wanted a prompt, in which case I prefer the fixed prompt, but whatever works for you. And as I say, I'll give you an example of these later so you can actually see how they look. So if I select multiple raw data here, this will give us a bit more information we can fill out. So now, as I was saying earlier, you need predefined terminators and separators for the RS232 communication. So these are going to indicate the split point between variables. You can think of it almost like a comma separated list, although the separator doesn't have to be a comma. So firstly, the terminator. So you can specify for both send and receive. Unfortunately, you can't specify anything at the moment. We have a predefined list of terminators and separators. However, it is in the long run our intention to allow you to specify one of these. But you should find most terminators and separators you would expect in this list, so shouldn't be a problem, I hope. Okay, so what these do is a terminator specifies the end of a send string. So to give you an example, you would start a command off if actually no, I'll wait until we get into the send receive. It'll make more sense there. But the terminator specifies this is the end of this command, and the separator is used to separate out different variables within one command. Okay, and the enable send complete variable here is it allows the application to report when the send is complete. So this is something most people probably won't need. And if you need any more detail on it, you can always email in and ask. Happy to tell you a bit more about it, but I think for the majority of you it's something we can just gloss over here. Okay. So next up I'm going to talk to you about the function elements. So I think the best thing to start with would be an RS232 send. So here you go, it's actually a serial port send. So this, it's an interesting interface we've got. So you select your serial port. Obviously we've only got one, so that's quite a simple property selection. Now you'll see this box of send values. So the way this works is basically you're going to send a list of variables over the serial COM port in ASCII format. So what we can do is we can either click on the add button here, we can double click here, or we can right click and add, and you'll see there's a pre-message and a post-message string that you can enter. So if you wanted to prefix something onto the value you're sending or add something to the end of it, you can do so here, and then you can simply select the value you want to send. So you'll notice you can actually send a hexadecimal value here. So there you go. You can also send pretty much any data type, and it will convert that through to a string and then send it suffixed and prefixed by the specified values. So what I'm going to do here, let's think of something useful to send. I'm going to send the value of an analog input. So here we go, we've got an analog input on channel 1, and I want this function to send that value, so I can select the analog input's voltage here, and I want to just make it obvious what that is, so we can say voltage 1, and then we'll suffix it with volts. There we go. So now whenever I call this serial send function, it's going to send voltage 1, the value, followed by volts. And because we've got multi here, I'm going to show you how you would do 2 channels. So we'll do voltage 2 as well here. Okay. And this is analog input 1. Well, there we go. So let me just rename these because it's confusing otherwise. Input 1, input 2, serial, send inputs. Okay, so another thing to be aware of is that this isn't going to be continuously spitting out data. This send inputs has to be called by something, much like an action set rule. So what we're going to do is we're going to need something to trigger it. So as per usual, this could be a button, this could be a timer, this could be a property trigger. So the best thing I think in this situation, I'm going to use a button. So let's go grab ourselves a rectangle to use as a button. Okie doke. And let's resize that to something sensible. What do we reckon? That's a bit small. 120. Oop. There we go. That'll do. So by pushing this rectangle, I'm going to want to send those input data, that input data, out over the RS232. Okay, so let's create the button now. Button send. We're going to link that to the rectangle, and we want to specify that when it's clicked, we send inputs. Okay. So just to give you a quick rundown of the format that these are going to be sent in. So you push that button, and then it will send the first value, so voltage 1, the actual value, the V letter for the units. Then it will send our RS232 separator. So you can see in here, or sorry, our send separator, I should be more specific. That's a space. I actually want it to come out as a comma. Then it will send the next value, so voltage 2, the value, followed by volts. And then, because there are no more values, it will send the send terminator. So we've got carriage return line feed here. Okay. So that's what we're expecting out. Now, I will test that now. So you can see here I've got my device connected already. So I'm just going to upload this project. There we go. Lovely, so I've got a nice big button on the screen now, and I'm just going to push that button, but before that I'm going to open up my terminal application here. So I'm using TerraTerm, but there are plenty of terminal applications out there that you could use. I'm going to connect to, so this is something to be wary of, you don't want to connect to the PanelPilotACE device. Okay, you want to connect to your USB to serial COM or whatever it is you're using. That is if you're using a terminal. Your device, if you've plugged your device in, then that's fine. So there you go. So now I'm connected to the appropriate channel, and now I'm simply going to push the button. And there you go. So voltage, the value, the V, comma, my separator, voltage 2, the value, and V. Okay. And so it's obviously entered a carriage return new line there, taking me to the next line. So that's what I would expect, because that was my send terminator. Okay, so that works as expected. Brilliant. So coming back here now, it's time to look at the RS232 receive function. Okay, so let's add a serial receive function element to the screen. Now this is where things get a little bit different, a little less obvious. So the serial send is maybe intuitive. The receive is, but there's a couple of things you have to understand about it before it makes sense. Okay, so let's just talk through the properties of this element here. So first we select a serial port. Okay, so you've got a name. Now the name actually becomes a bit more important than just a variable name here. So by default, this name is what's going to be effectively the trigger of this receive function. So in order to determine what serial receive element handles commands over the RS232, you need an identifier at the beginning. So this name by default acts as that command, if you will. So for example, if I had the name A, by sending A followed by a separator, followed by a value, followed by a terminator, it would immediately recognize this function as the one that had to handle those values. Okay, so hopefully that makes sense. Now, that's not very helpful in my opinion, because the name should represent what the element does. It shouldn't be used for that in particular. So that's why we have this receive alias name. So let me just put a sensible value in here. So receive value. And then what I want to do is actually use this alias name to specify the command that triggers this. So for example, I'm going to name the command update. Okay, and so now by sending the word update followed by the separator, the receive separator to be specific, that can be different to the send separator, followed by however many values I specify here, ASCII values of course, it will update what I tell it to. So let me just give you an example here. So the receive values, these are basically telling it where to store the values that it receives. So for example, let me just create somewhere to store this. Now don't forget, it's going to be coming in as a string. So I wouldn't recommend storing it directly into a number variable, for example. The best way to handle these receive values is to store them as a string and then use an action to convert them, if you will, into whatever you need. So what I will do is I'll give you an example here. I'm gonna actually put the value directly into a text box, so that we can see exactly what we're receiving. So this is our text. So I'll receive value, and it's going to put some dashes in it by default so we can identify it and stretch it across the screen. And then just align the text to the center. Okay, so we'll have dashes until we receive a specific value. Okay, so coming back in here, we are going to store this receive value. So we're only going to receive one value for the sake of argument here. You could receive as many as you like as long as they're separated correctly using the receive separator. And I want to store that value within the text property of this text box. So now whenever I receive the word update followed by the separator followed by any string followed by the terminator, the value I sent will be displayed in this text box here. Okay, so now there's just one more thing to look at, and that is this action element at the bottom here. So this action basically allows you to process that data. So this will be run once the download or the receive has been completed, the values have been stored, and then you can run an action. So for example, this action could take that text value we've just downloaded and put in the text box, and do something with it. It could convert it into a number variable, which I could do now. So let's do that. So if I create a number variable, so as I said before, do not download or do not put a number into the receive box. It may not handle the conversion correctly. Put it or send it to a string, and then use the action to convert that string into a number or something else, simply by setting the number variable equal to the text box. So I'll do that now. So I'll call this received number. Okay, and then we'll have an action set rule. Action process receive. Okay, and all we're going to do using this is set that number variable equal to the contents of our text box, which will be equal to what we received. Okay, and this action set rule actually handles the conversion for us. So if the types don't match, like in this case, it will try to convert that string to a number, and if it fails, it will turn it into a nan, not a number. But what we don't want is to download it and try and store it straight into a number, and then if it's not a number, the data could be lost. We don't know. This is just the safest way of doing it. Okay. So what I'll do now is I will run that action. So action process receive. So when the data is received, the value gets stored in the text box, the action is called, the action then sets the variable equal to the value of that text box. Okay, so there's no way for me to really show you it at the moment, but just take my word for it that that variable will be getting updated. Okay, so I guess it's time to demonstrate this. Oh, sorry, there's one more property, the enabled property. So this can be changed at runtime through an action set rule. So you could start the receive disabled. You could enable different receives at particular points. Okay, so all that does is determine whether it's listening for this particular receive function. Okay, so what I'm going to do now is I'm going to upload that new application. Okay, and let me just check what I'd specified as my receive separator here. Okay, so the receive separator is a space. So I probably should have changed it to a comma, but we'll work with a space for now. And the terminator is just the carriage return. Okay, so I've got my terminal open again here. And so just to check, my alias is update. So update, you can't see me typing because I'm not in terminal mode. So because I'm using raw data, there's no need for it to mirror the data back at me to see. If you have terminal mode selected, and I'll show you this in a sec, you'll actually be able to see the data you're typing. Okay, so space, I'm just going to type hello world without a space, but with a capital W, because a space is a separator at the moment and I don't want to get that confused. And then I'm going to hit enter. And as you can see, I've now got the hello world text written on my screen in that text box. So there you go, RS232 receive working as expected. Okay, so now as promised, I just want to take you through the different terminal types so you can see exactly what's going on in each of them. So all the raw data, so single raw data simply removes the separator from the send, so we're not expecting more than one bit of data to be sent. I don't see the point in using that over multiple raw data, so I generally stick with multiple raw data. So what I'll show you instead is the scroll up with prompt. Okay, and I'm just going to upload that to the device now so that we can see it. Okay, and now if I disconnected, so if I just reconnect to the device there, so if I hit enter there, you'll see it's given us a prompt now. So this is It's telling us that we can enter data. And now you'll see if I enter data, so update, space, test, enter. Data has been entered, my screen has been updated, and I can see exactly what was going on there. And you'll notice that the new terminal line has gone on the line below that. So when I show you scroll up, fixed scroll prompt, you will see how that differs. But basically it operates the same, it's just a more user-friendly way when you're using a PC terminal and you're actually looking at it. Okay, so I'm just going to go back in here, and now I'm going to select fixed prompt. And I'm going to upload that to the device. Okay, and so I should still be connected. So there we go. Now I didn't clear my screen, but the way this works is that prompt is going to stick at the top. So I'll just clear my buffer there. There's my prompt at the top, and I'm going to once again update space value, enter. So my screen's updated and that prompt remains fixed at the top there. So you can't see your previous history, but you don't get the mess of scrolling down the screen as you go. Okay, so that hopefully gives you a brief understanding of just what those types mean. Don't forget, if you're talking machine to machine, so you've got another embedded device listening, you probably want the raw data. It probably doesn't want a load of data spat back at it as you're going. So those prompts, while they look nice to us, will not probably be a good idea, but I'll leave that up to you. And that is all for this RS232 PanelPilotACE tutorial video. If you have any questions, please feel free to email us. I will put this example application on the website so that you can give it a go yourselves. Thank you very much for watching.